Hey guys, this is Ronald, and welcome to MathBase. Today we'll talk about the unit circle, but before that, let's talk about pyramids. This is the Pyramid of Zoser. It's the oldest pyramid known to man, about 46 centuries old, give or take a few decades. This is also a pyramid, but of a much more recent creation and using a computer. What both these pyramids have in common is the use of trigonometry, which is the study of triangles. Without it, the Egyptians from 46 centuries ago and graphics designers of today would not be able to build these structures. In today's world, trigonometry can be seen in many industries, from making complex machinery, to CGI in games and movies, to designing buildings, and many other applications. But no piece of maths has withstood the test of time without a solid foundation. Trigonometry is no different. We need to understand the foundation which holds it all together, a method to our madness for dealing with angles, triangles, and various other shapes. With this foundation, all the established conventions of trigonometry can be put to good use. The foundation I'm referring to is known as the unit circle. In essence, the unit circle is simply a circle with a radius length of 1 unit. It doesn't matter if it's 1 inch or 1 centimeter, as long as it's 1. That's what makes it a unit circle. But the circle on its own doesn't have any real meaning unless we place it on a Cartesian plane, like this. This way we can study its properties in two different directions, commonly known as the x and y directions. So let's imagine the x-axis is the ground, and the circle's radius is a plank, 1 unit long, lying on the ground right here. And we placed a ball on the end of it. If we were to lift the plank on one end along the circle at about 60 degrees, you would now have a plank inclined at 60 degrees from the ground, with the ball ready to roll back downhill. But how high up is the ball? And how far to the right? Or in other words, what's the ball's coordinates? While it is easy to accurately measure this on paper, it might be impossible if this was a real ball coming down on the side of Zoser's pyramid, for example, which by the way is over 60 meters tall. And we don't always have access to such measurements, and it's sometimes easier to just measure the angle of inclination. In this case, we'll take it to be 60 degrees. Firstly, sine means height, and cosine means width. This means we can replace y for sine theta and x for cos theta. If you wish to learn more about why that is, please have a look at my video explaining sine and cosine. Links in the description. So to find the height of this ball from the ground, we can use the sine of 60 degrees, giving us about 0.9 units. As for how far across the ball is from the origin, we can use the cosine of 60 degrees, giving us exactly 0.5 units. The calculations can be done using the special triangles. I'll cover that in a separate video. This one's more about how it's all connected. So now we can see the ball is about 0.9 units up high and half a unit across from the origin, giving us the coordinates 0.5, 0.9. And that's it. Problem solved. So in summary, when you have a point on a circle and its angle, theta, you can figure out its x-coordinate using cos theta and the y-coordinate using sine theta. And these are indicative of the width and height of this point from the center. Together, these properties form what is known as the right-angle triangle, which opens up the path to using sine, cosine, and tangent, and thus enabling us to do trigonometry. Just remember, for this to make any sense in maths, as a standard convention, the angle must be measured from this point and counterclockwise. And there you have it, the unit circle. You could think of it as a building block for trigonometry. It's not something we often use in maths. That's what trigonometry is for. So, I hope this video has helped. If it has, please leave a like, comment down below, and subscribe. Thanks guys. See you in the next one.